All right, lesson 810, systems of equations. It says that we have two or more equations with the same variables. That is the definition of what a systems of equations is. Basically, what's happening is there's two or more equations on the same graph, which make two or more lines, however many equations there are, and where they intersect, that's the solution. The solution is where they intersect. The solution should be written as an ordered pair. In other words, make sure that every answer that you give is an ordered pair. The x value, the y value of that point where they cross over each other. We are going to do this two ways. When you get in Algebra 1, there'll be an additional way, but we're going to graph the lines, and we use slope-intercept form. So you guys did really well with graphing with slope-intercept form. You just graph them both and wait till they intersect. Now, I can tell you, the graphing of the lines is the least accurate, because what if you hit somewhere out in the middle and not on a corner and you don't know exactly what the numbers are? That can be a problem. I will tell you that all of the problems you guys are given, they're going to hit on a corner. So if they don't, go back and double check. Also, some suggestions when you graph. I'll show you, I would graph more than just 2 points if you can. Just graph as many as you can on the coordinate grid, and use a ruler to make your lines really straight. And then also we're going to use the substitution method, which is more, I'm going to call it more algebraic. You're actually solving equations, and I think probably you might like that better. I don't know. All right, let's start off with the graphing ones first. So basically what's happening here is we're graphing y equals 2x and y equals x plus 1 on the same graph. So I'm going to go down to a graph to put these on. Here they are. If you're graphing these, don't write the whole grid in. Just do like the little tally marks or tick marks for each number, and you really don't need that many. So let's review. Remember, y equals mx plus b. That's how we want these, the form we want. The b is the y-intercept, so that's where you start on the y-axis. This one's the y. And then you count the slope. So if I need to graph y equals 2x, what's the y-intercept of that? There's no number at the end, so what is it? 0. So I would start right here on 0. And then I look at the slope. What's the slope of that equation? This one. 2. Can you make it a fraction for me? 2 over 1, which we know that means rise 2, run 1. So here's what I'm going to ask that you do, okay? I'm rising up 2, running 1, and putting a point. But I don't think you should stop there. I think you should rise 2 more and run 1 since we can. Bless you. Now, I need to tell you, just to be equivalent, and sometimes you might have to do this, rising 2, running 1 right is exactly the same as falling 2, going 1 left. You see that? Rising 2 and going 1 right is the same as falling 2 and going 1 left. See how they're both going uphill for the positive slope? So you should try to put in as many points as you can. I'm going to go down 2 more and 1 more left. And therefore, I can now put in my line. And when you do these lines, remember, you go as far as you can through the graph. And you put the arrows on the ends. Okay, now let's do the other one. I'm going to do the other one in blue. So this one, where do I start on this one? The one in blue. Where's the y-intercept? 1. So I put my point right here on 1. And when I do this, what's the slope? Tori? What's the slope? 1 over 1. So rise 1, run 1. Rise 1, run 1. Rise 1, run 1. I want you to be aware I can fall 1 and go left 1. Okay, does that make sense to you? How you can go in either direction as long as you're going in the right direction. Okay, I'm going to make this line. And it crosses right here. So you would write that the solution to that is 1, 2. Everybody get that? You graph them both and find the point where they intersect. Try to make as many points as you can. Questions about that? All right, let's try one more. This one, the first equation is y equals negative x. And the second one is y equals 1/2 x minus 3. So I'm going to do this one in red. Y equals negative x. What's my y-intercept? 0 again. What's my slope? Negative 1 over 1. So that means I fall 1, run 1. And I'm going to fall 1, run 1. And keep going as far as I can go. That means the equivalent to that would be what? Going in the other direction. What would be equivalent?
Rise 1.
Rise 1, go left 1. Does that make sense to you? It's going the same direction basically. So my line for that equation then would be this. Okay, let's do the one in blue. Y equals 1/2 x minus 3. Where do I start on that one? Negative 3. What's my slope? 1/2. Rise 1, run 2. Rise 1, run 2. What's the equivalent to that if I want to fill in the other way? Fall 1, left 2. Good job. So let's make a line. But I think we found it on the first point, didn't we? Did I? Yes? Okay, good. I just want to make sure you understand what I'm doing. So the answer, I'm going to circle in purple because red and blue make purple. And my answer would be what? What point is that? 2, negative 2. Questions about that? You graph them both however you have to. Find the point where they intersect, and you've got it. Now I got to tell you two things. There is this great possibility that this could happen. Okay, so obviously this isn't these two, okay? So you might want to just do graphs without even putting numbers on it. But there's this possibility. If I have one line going like this and another line going like this, where are they ever going to intersect? Never. So the answer to that would be empty set. You would have to answer empty set. There is no point. There's one more like this that's just the opposite. It would be if you went and graphed one line and then you go graph another line right on top of it because they might have it in a different form and you have to change it around. How many points do they overlap or intersect? All of them? Here's what that's called. Infinitely many solutions, because it's all of them and lines are infinite. You could say IMS. IMS. So those cases of empty set and infinitely many solutions are pretty rare, but you just need to know that they do exist. questions about the graphing part. So that's part of it. Let's look at substitution. Here's what happens with substitution. You're not using graphs, you're just using algebra. If you're lucky, you'll get some like these examples. I've got one more that I got to put on here that's not quite as easy. Here's my first system right here. The y equals x plus 2, and the other equation is x equals 1. Well, the good news about this, they've already given you half of the answer. When they say x equals 1, guess what? It's 1 in the ordered pair. They're giving you one of the answers. It happens to be a vertical line through exit 1, but that's where it's going to have to cross the other. Okay, as far as the substitution part, you substitute this value into the other equation. In other words, y equals 1 plus 2. What would that make y? 3. So your ordered pair is 1, 3. That's probably as easy as it will get right there. But they get a little, you know, they're not all going to be that easy. Okay, the second one, y equals 2x minus 3 and y equals 5. So they're giving us half the answer. Which one are they giving us?
The y.
The y is 5. So you go ahead and fill that in. That means you're going to take this 5 and you're going to plug it in the other equation for y. So you would write 5 equals 2x minus 3. And then you got to solve for x. This is a little more involved with this one. What would I do first to solve for x? Add 3. So 8 equals 2x, and now what?
Divide 2x by 2.
Divide by 2, and it says x equals 4. So there you go, the ordered pair 4, 5. Well, it might let me write 4. There we go. Okay, one more like this. Y equals x plus 4 and y equals 0. So which one did they tell me?
The y.
The y is 0. Substitute again, I plug that in there for y. So 0 equals x plus 4. How do I solve for x?
Minus 4.
Minus 4. X equals negative 4. Okay, so if they give you x equals a number, y equals a number, they're giving you half the answer. Okay, let's look at one where maybe they don't give you that. So I'm going to try to do it up here on the top. Well, maybe not. Let me try to do it down here. So here we go. My two equations are y equals 2x plus 4. And the other one is y equals 4x. Okay, so we're doing this one right down here. Y equals 2x plus 4 and y equals 4x. They didn't tell us either one, did they?
No.
No, but we still have to come up with an ordered pair here in just a minute. But we can use substitution. When we know that y is 2x plus 4 and y is also 4x, I'm going to take this 4x and plug it in the other equation for y. So I would have 4x equals 2x plus 4. Does that make sense? I substituted what y was equal to in for it in the first equation. And we can solve this equation. We've done these, a variable on each side. What do I got to do with the variables? Layla?
I put minus 2x on each side.
Minus 2x on each side. Good.
The 2x minus negative is minus 2x crossed out. So
2x equals
4.
4. And the last step?
And then divide it so x equals 2.
Divide it by 2 and x equals 2. So I'm ready to fill that in my ordered pair over here. X equals 2. And then I do one more substitution. I got to find the y. Where would be the best place to plug that in? I know x is 2. Where would be the best place to plug that in?
First one.
The first one?
No, second one.
The second one, y equals 4 times x. So we're going to take it over here and say y equals 4 times 2. So what's my y? 8. And therefore we've got that extra point.